Okay, we are now going to talk about how to find the period of a mass spring system for an object undergoing simple harmonic motion. So imagine we have a mass attached to a spring, and I'm going to go ahead and draw it oscillating side to side. So this is some mass, and it is oscillating. Let's call this like x equals 0. This is its mass point, and this is its min point. And again, the period is the time for one complete cycle. So to go all the way to one side and then all the way back to where it started. So the object could be oscillating back and forth, or side to side, or it could be oscillating up and down. Either case, this will work. So the equation for the period, so again, this is period, is 2 pi square root of mass over k. And again, this is the mass of the object attached to spring and then k is the spring constant. Cool. So we have that equation. We'll go ahead and circle that. Now let's go ahead and solve. I have 2 problems right here we can solve. I encourage you, go ahead and read problem number 1 below to yourself. Try it on your own. Go ahead and pause this video right now, and then you can come back and look at how I solve it. Great. Okay, so now that you've tried it yourself, we'll go ahead and go through it together. So, okay, we have a mass, oscillates, blah, blah, blah. Oh, cool. The spring mass system, it's brought to the surface of the moon. What will be the new period of oscillation? So on Earth, we know it's T, we have M, and we have K. Cool. So on Earth, we know period is 2 pi root M over K. So now this is brought to the moon. Okay. So what changes when it comes to the moon? Does the mass of the object change? No. Mass always stays the same. Mass is not affected by the acceleration due to the gravity of the moon. K? That's a spring constant. That's just the constant of the spring. That doesn't change either. The only thing that's changing is acceleration due to gravity, which is not even in this equation. So does it change? No. Cool. So it's just T, whatever it was originally. Okay, so we have one more problem we're going to solve together about a mass spring system. Cool. So again, what I encourage you to do is go ahead and read this problem, try it on your own, and then you can go back and watch one way to do it. And I'm sure you'll get it without me, but always good to try by yourself first. Cool. So after you've tried it yourself, now you can follow along for my explanation. So we have a mass M attached to a spring constant K, oscillates with a period T on the surface of the Earth. So if a new spring is used that has W the value of K, assume the mass M stays the same, what happens to the period? Great, so let me just write down what I know. So originally, we have what? The mass is M, K is K, period is period. So now we have a new spring. Cool. So I'm going to call it new spring and just write down all my data. Okay, so new spring sounds like M still stays the same. Double the value of K. Okay, so the stiffness of the spring is increasing. Period, we want to find. Great. So I'm going to go ahead and write down my original equation for a period of a mass spring system for simple harmonic motion. So that's 2 pi root M over K. Cool. So now let's look at this new spring. So what's happening? Okay, K, we are doubling. So if we go ahead and if we're increasing K right here, what's going to happen to period? Oh, definitely, period's going to decrease by some factor. So this is a good way to just guess and eliminate your answer if it's a multiple choice type problem. But we'll go ahead and go through the math anyway to get an exact answer. Cool. So I'm going to call this, so for new spring, we have 2 pi root M, I'll call it T new, M is still M, K is now 2K. So I'm going to go ahead and see how we can get this in the same form as the original equation. So I'm looking to get 2 pi square root of M over K. Okay. The only thing that I have different is this 2 on the bottom under the square root. So I'm going to go ahead and pull that out. So it's 2 pi root M over K times 1 over square root of 2. So this whole term right here is just whatever T was originally. So we know this whole thing is just decreasing by a factor of square root of 2. Square root of 2. So the new period is just going to be, I'll call it T new, is just going to be T times 1 over square root of 2. Boom.